I like to start with a slide introducing myself. So you kind of know a little bit of my background and where I'm coming from. So right now I work at Microsoft. I'm an Azure software architect. I work on the Azure storage team. But if you're familiar with me at all, it's probably because I've been an author of about 18 different books over my career on Windows, C, C++, .NET, C#, and Windows Runtime. Some of my book covers I put up here on the slide. Most recently, I did a 6.5-hour free video series on how to architect distributed cloud applications, and it's technology agnostic, but it is hosted on the Azure.com training webpage. And then at the bottom, there's ways for you to contact me there. I would just show you briefly. This is, if you go to the Azure.com website, these are, I wanted to get my hair cut so bad before we recorded these. And I told the stylist the wrong number. So they ended up like cutting off everything. And every time I look at it, I think that is not me. That's somebody else up there. We had to turn the lights down in the room because of the shine and everything. But it was either that or postpone the recording in the studio, and it took so long to set that up. Anyway, I'd highly encourage you to check this out. I think there's a lot of good stuff up there, if I do say so myself. Okay, so I only have this one slide, and then the rest of it will be code and demos. Oh, thank you very much. Yeah, okay, great. Thank you. I asked for this, and they delivered. It's cold. I love it when it's cold. But this doesn't really slide out. All right, it'll be good for him. So I have worked most recently before, I don't want to say switching to Go, because I build SDKs for the Azure storage team, and we build the SDKs in lots of different languages. And well, the background story is that our SDKs are many years old, and they have a lot of technical debt in them. So I was architecting a new way of designing these SDKs, and all of the people in the Azure storage team said this will be breaking changes for all our customers, so we are afraid to go ahead and do this. Can you do this in some programming language for which we don't have an SDK first, so we don't piss anybody off? And so we looked around to see what kind of languages were gaining traction, and we said, hey, we don't have a Go SDK, why don't we do it in Go? So that was the new architecture of our SDKs, was first done in Go, and I started work on that about a year ago. And I've learned to like Go a lot. Like any language, there are some things in it that I wish was a little bit different, like error handling would be one. And, generics or templates or something like that would be nice as well to have. And, but, there's, like Anders Hallsberg at Microsoft, he used to say there's two kinds of programming languages in the world, the ones that nobody uses and the ones that people complain about. So anyway, but there's a lot of good stuff about Go that I really like a lot. So as we were working on a bunch of our projects, having used C# really as the mainstay of my languages for the last 15 years, and C# has enumerated types in it. And Go does not have any kind of built-in enumerated type mechanism. And I really found that missing for me. So I started thinking about, so what is so great about enumerated types that I find it missing for me? And so that's what this slide is about, is why I think the enumerated types is a really useful thing. Enumerated types, it enforces compile time type safety, which means that your code is more robust. So an enum is a data type, as opposed to using something generic, like an integer or a string or some other arbitrary type. If you see a method that takes a string, you could pass anything there, or an integer, you could pass anything there. But if you see a method that takes a color, then you have a better sense of what needs to be passed there for that. And if symbols are scoped to enumerated type, so there's, let's say, a color type, and it has some symbols on it, like red, green, and blue, well, then you know what is legal. And you can get discovery in your editor of choice when you type in, color dot, and then you see the possible options there. That makes writing the code better, and again, more robust at compile time. Enum symbols in your code makes your code more self-documenting. So as other developers are working on the code or reading the code later, they can see, oh, this is a color and I'm passing in red, right? It makes a lot of sense. That makes the code more maintainable over time. So there's an example of a variable called color of type color, and I'm initializing it to color.red instead of using an integer like 1 for red, let's say. And enums restricts values to a small set of legal values. Not all possible colors are legal for a particular method. It could be that maybe only red, green, and blue are supported for something. So the enum makes that obvious. What are the possible legal subset of values that you can use here in this context? Enums also have things like string and parsing conversions that are available in them. This is very useful for command line arguments. The user can pass into the command line, here's a string as a command line option, and then you want to parse that into enumerated type so you can pass it around the rest of your code base. Or you might have a color, that has a value of 1 in it, but when you want to convert that to JSON or XML, or you want to just make it a string so you can log it in a file somewhere, you don't want to put the number 1. Nobody knows what 1 is, but maybe you want to put the red or green or blue there instead. So that's an incredibly useful and valuable thing to be able to have. And if you have more like proper enums in the language, then you can go and ask it, what are the possible set of legal values? I would like to be able to walk up to a color and say, so what colors do you support? Red, green, and blue. And then you can use that to offer the user like a menu of legal options, maybe in a usage output for a CLI application, for example. So there's or to some other client application, maybe even across the wire, and say, oh, here's the possible set of legal values. So these are the benefits that I think enums really bring. And so that was my only slide. So now we can switch over to some code. So first I'll walk through the idiomatic way of doing enums in Go, since there's no like built-in enum thing. So the idiomatic way of doing it is you would define, let's say you type, and here I'm calling it color idiomatic enum, but imagine it just says color, okay? And you would pick an underlying data type for this. Here I'm choosing a 16-bit signed integer for the underlying value. You could pick something else, of course, if you'd like. Then you would typically define a bunch of constants of that type. And here's some comments if you want to read those. Each constant, you pick it a name, give it a name. That's the symbolic name, if you will. And then you say, this is the type. And in Go, you could use iota over here to mean 0, and then the other values would be 1, 2, and 3, respectively. Or, of course, you could hard-code numeric values there if you want to, if the hard-coded numeric value has meaning to you. Now, for the names, because these are going to be defined at package scope, when somebody wants to use one of these, they'll give the name of the package dot, and then everything that's at package scope will appear in your editor of choice. So if you want to group them all together, then you probably want to prefix them with the enum name, like color none, color red, color green. They all start with the word color so that they're grouped together. But of course, color idiomatic enum is also going to appear in that grouping too, because it's also at file scope, and it'll be alphabetized probably in that list, and that's not really a legal value, right? That's a legal thing for the package, but it's not a legal symbol for this enum type. But you can do this, and of course this is what people do, and they can get very far with this. Now, if you want to be able to convert your enum symbol to a string value, or I'm sorry, the numeric value into its symbol or its string equivalent, then what is recommended in Go is that you create a function called string, and it returns a string, and it takes one of these values as its receiver, method receiver, and then you would do a switch on this, and then you would return the proper string for each of the cases that you have in there. One of the things I don't like about this is that as you go and you change these symbols, maybe you add some or you change the spelling of it or so on, then of course you have to remember to update this method as well, right? Otherwise things will go haywire. And then if you want to be able to parse them, you would probably write a parse method, something like this, and it would go and switch on the string, and then on base to the values here, you would go and set it to the values. And you can do all of this, and this is what many people do, in fact, and the code runs very fast. It's pretty efficient code that gets produced by the compiler. The problem for me is really the maintenance of it. As we're adding enum symbols, we have to update these two functions. If you change the spelling and so on, there's just a lot of maintenance that happens there. There are other, so the first example that I'm going to show here in this code is how we would use this. So here, I've created a variable C of my color idiomatic enum type. Again, just pretend it says color there. And then I'm initializing it to be the color red. And then as I step through the code in the debugger, I'll do a print here. Now when I do this print, the printf, that's my little helper function, but it effectively just calls the regular printf function internally. It's going to have a %s, and so the string method is going to be called on this color red, which has a value of 1. And then we will see in the console window that it has converted into the string symbolic name of red, which is very nice. Here, I'm going to call my parse method. I'm passing it in a string of blue to go and try to convert this to blue. And assuming that is successful, I will then display it, and then it calls string again on the other side of that. And so it converts the number red, green, blue is 3. Blue is 3. It converts it into the string of blue over here. Here I'm going to try to go and convert purple. This was not one of my predefined string values, and so this would produce an error over here. So we jump into the else clause, and then I display the error, couldn't parse purple into a color. That was my string error message that I put there in that method. And then another typical thing to do here, sometimes you end up with a number like 1, 2, 3. This could come in maybe over JSON or over an XML payload, and you're going to try to convert it into your enum value, but you don't actually have a value for this. This can happen typically with versioning scenarios where the service supports a new thing that the client code doesn't know about yet. So you haven't added that symbol in the client code, but the server's returning this new value back to you. So because of the SDKs that we build, this is an important scenario for us, versioning. We do it all the time. I wanted to make sure that the enums round-tripped properly. So in this case, let's say the number 1, 2, 3 comes back instead of 1 or 2 or 3 for red, green, or blue. You can always just convert it to a color by just doing a conversion, which is what I'm doing on this line of code here. Then if I do a switch on this, it's going to go to blue? No, okay, it's jumping over. Right, so I could have a case for 1, 2, 3 if I really needed to. Right, I don't have a symbol for it, I could. And then I could say, okay, I don't have a symbol for this, and I can get the numeric value, and I can still use it, right? It's still a usable thing if I get this value that my enum didn't know about. And that's very important for round tripping with things that are out of sync with each other for different versions. Okay. And then another thing that's kind of nice to have, which I mentioned at the bottom of my slide that I showed you, is it's nice to be able to say to an enum, what are all the legal values? So I did write a method called color method, and you could write this method yourself for your own enums, and it will return back a collection of key value pairs with the symbols and the numeric values. And so here we can see none is 0, red is 1, green is 2, blue is 3, and that's useful for things like CLI usage outputs and some other scenarios as well. But again, I wrote that method manually myself, and so if I add a new enum symbol or remove a symbol or change the spelling of a symbol, I have to go and keep that method up to date as well so that everything is working just fine. All right, so that's the idiomatic way of doing enums in Go that you could have been doing for years. But I didn't like it. So I felt that it wasn't giving me enough. So let me show what I've done. So I have created a package on GitHub, so you can all have access to it. And it's Jeff Richter enum is the URL for the package. And as you can look at the index, you can see what kind of methods it supports. So mostly what it is providing are some parsing methods and some string methods. And what these methods do internally is they use Go's reflection API, which is what C# does as well when you're working with its enums. It uses its reflection API in order to convert the numeric values into its symbolic values and vice versa. So basically I'm kind of replicating this C# behavior or feature that I've really grown to love over the past 15 years or so into Go. And then there's also another function here called getSymbols at the top. This is the one that will automatically enumerate all the symbol values for you. Again, they all use reflection in order to do that. Now, reflection has a bit of a perf hit to it. But typically you're doing these kinds of conversions at the edges of your program, not in the main course of your program execution. So the performance hit doesn't execute the main thing. It's really just when you receive an XML payload, you might parse things, or a JSON payload where the user types in some string at the CLI, and then you're converting the string value as the command into one of these enums, and then you're just going to use as a numeric value as you pass it around your system. So there's this slight perf hit, but it usually happens at the edges. It happens only once, and it doesn't happen in the mainstream course of your program execution. So we have found this very useful. So now let me demonstrate how this works. So this is my example reflection enum over here. And I'll right-click and debug this one. And then I'll show you what it looks like to create an enum and to work with it using this package. Okay, it's getting the debugger going, and here we go. So first, let me show you what it looked like to define the enum. So it really starts here. So I've defined my type called color, and it's also in int16, very similar to what I did with the idiomatic example. I have found it useful to create a global variable called eColor. The E stands for enum. I like I for interfaces too, by the way, which Go doesn't do, but I tend to like that. It's easy to tell what something is. These little visual clues are helpful. In any case, I use the eColor, well, E at the beginning to represent that this is an enum. And you just have to set this to be some instance of the enum. It doesn't matter actually which instance this is. Then, for the symbols, because I want the symbols to be scoped to be within this data type, the symbols are methods. So I have a symbol called none. And because they're methods, you have to have parentheses on them. Right? In C#, we would use these as properties. We would have getters and setters. But Go doesn't have those, which I'm okay with. I never really liked the properties in C#. It made it unclear as to what was a field, a piece of state, and what was an action. Right? And one of the things I do like about Go is it's always very clear that this is a piece of state or this is an operation that's being performed. So these require the parentheses here. That's kind of the tax, if you will, of using this pattern. All of these methods are methods on the color. You'll notice that these methods take no variable as a receiver because they're not going to operate on anything that's passed into them. They're really just, these methods are put on this type for the purposes of scoping them to the type. And then they all return the enumerated type. In this case, they all return a color. And then you initialize them. So none has a value of 0, and red has a color of 1, green a color of 2, blue a color of 3, and so on. So you can make them be whatever numeric values you want. I can't use iota, but I'm okay with that. I'm not usually a big fan of iota either, where things get assigned implicit values. Kind of bugs me. The string method, though, becomes really simple to write. It goes to my enum package from GitHub, and then I have a function in there called string for an integer. Most people use enumerated types over integers, but you can have enumerated type over a string or over a structure of some sort and so on. But 99 times out of 100, people will use enumerated types over an integer type. And I have some conveniences that are available if you are creating an enumerated type over an integer type. So this string int will convert the enum numeric value into a string value if it's an integer type. And you pass in here the method receiver, in this case C, for the color, and then you pass in what is the type of C to get it started. Now what this method does internally, and that's all you have to do to implement the string method, right? You just write that one line of code to implement it, and then my function will do all this reflection magic underneath the covers in order to return to you the string symbol for that numeric value. I'm not going to walk through that code because it's a little tricky on the code, and I don't know how many people are familiar with reflection. How many people have used reflection? Well, okay. I'm wildly impressed. I'm still not going to walk through it, though, in spite of that. But I will explain in words what it does, okay? So what it does is it calls each of color's methods that take no arguments and returns a single value of type color, right? So the reflection code enumerates all the methods of the color type, looking for methods that take no arguments at all and return only one value, which is the same type as the enum itself. So those would be those methods up there, none, red, green, and blue. So my function is going to end up calling all of those methods internally. It may short circuit and not do all of them. Each time it calls one of those methods, it gets a value back, 0, 1, 2, or 3. I compare that value with the value that's in C. And when I have a match, then I will return the name of the method that returned the match, right? And that's the string, right? And then, so it doesn't have to enumerate through all of them if it finds the match very early on. And this means that you can add new methods here, and you can remove methods, and you can rename methods, and so on, and my method using reflection will just do the right thing all the time, right? So you don't have to maintain your string method anymore. It just always works. For parse, it's a similar thing. On my enum package, I have a parseint method over here, and you tell it what type you want to parse it into, a color. Again, uses reflection. You pass in the string value. This gets passed in as an argument to parse over there. And then I've added some conveniences, like whether or not you want to do a case-sensitive comparison or not. Right? So you can pass true or false for case-sensitive or case-insensitive. And for integer parsing, I also have this concept of strict. And if you say true for strict, that means if it's not a recognized symbol, this will give you an error. But if it's not a recognized symbol, I'll then try to convert the string into its numeric or integer equivalent by calling A to I. And if I'm able to do that successfully, then I'll take the binary value of that string that had a number in it, and I will just put that into the variable. Right? So the parsing will be considered successful. And again, this is very useful for that round tripping scenario, especially when you have different versions of things on the client and the server. So this method will return the value that it has, and possibly an error if it can't do the parsing. And then if we are successful, no error occurred, then I type assert it into my enumerated type, in this case a color, and then I assign it into the variable that's passed in as the method receiver, and it has a star there because I'm going to change its value internally. And then I return the error back to the caller. And so again, you write this code just once, and then everything just magically works, right? You can add new symbols, you can remove symbols, and so on. The comment above explains what parseint is doing internally. So what it does is you've passed in a string. So it will now enumerate the methods on the color type, and it will do a string comparison. And whether you want it to do a case-sensitive or case-insensitive, that's up to you. So when it finds a method that matches the name, it then calls that method, again using reflection, that returns the numeric value back, and we have a successful parse. If I go through all the methods, and none of them, the string names of the methods, match the string name over here, then if you've turned strict off, I'll then do the A to I conversion to see if I can convert the number into the string number into its binary equivalent, and then if so, I'll return that value back. So that's what parse is doing internally. Now you might say that these methods can be slow because they're doing reflection, and maybe in your program you tend to call string and parse all the time, and you would like to have improved performance. If that improved performance is a nice have for you, then there is a technique that you can use where I show it over here. Again, all this is code's available on GitHub that you can download it. I've created a global variable color tables, and it has a map of colors to strings, and it has a map of strings to colors. Right? So this is one is doing the string method, and the other one's the equivalent of the parse method. And then I have an init function in my package here that allocates those. And then on my enum package, it calls this getSymbols method, and that will enumerate all the symbols for the type, and then I can go and put them into these maps. So this happens once at program initialization time now, and then you can have a string method. You would call it string, not string fast, but this is the way you would implement it internally, and then you would just go and look it up in the map, right? And now you would be doing the conversion from the binary to the string equivalent in a very fast way because you're just grabbing it out of the map. And then parse is the same thing, but in the reverse. A little trickier if you want to do the case insensitivity in the strict part here, but not too bad. So there's a couple different ways that you can use this stuff depending on what your performance characteristics and needs are. But the main goal here is that the enum mechanism is all self-regulating, right? You can just create symbols. That's all you have to think about. Everything else just works for free. So I can give a demonstration of the code now that uses this. I have a variable C. It's of type color. and I set it to eColor.red. Right, so this is what the code now looks like for this. eColor means this is a enumerated type color, and red, I need the parentheses there because it's a method. It's not a field. And that goes and initializes it to so the variable C will have the value 1 in it, right? It is the size of a 16-bit integer, and it does have the number 1 in it. And then here, if I call printf, just like I did in the previous example, this internally calls string, but now it's calling my string method, which internally calls my enum package's string int method, and we get back red over here in the console at the bottom. And then here, if I want to go and parse blue, you'll notice that blue is in all lowercase letters, by the way. It's not an uppercase B, so I don't have a symbol called blue with all lowercase letters. But because I've decided that for this enum, I will accept case insensitive work, so I'll accept lowercase letters, this succeeds and does not produce an error. And then you'll see here it says blue, but with an uppercase B, because now it's been converted to the proper symbol when you do the round tripping. And here I'm going to go and look up purple. I don't have purple, and so we get an error over here, and then it just says couldn't parse purple into a color. And then here's the 1, 2, 3 scenario where you just happen to have this number for whatever reason. You don't have a symbol equivalent for it, but you want to make it a color. So I do that. So now the C has the 16-bit integer in it of 1, 2, 3. Then I can do a switch statement on these. This is what a switch looks like, where I want to do a case against red, blue, green, or I can look specifically for 1, 2, 3 if I'd like. And we will eventually get down there. Okay, and then here I say there is no symbol for it, but I can still get the value 1, 2, 3 out of it. And then I can go and parse this and display. Why does this display green? Oh, this is just demonstrating parse. So this is parsing a string that has an OX2 in it, right? So let's say this came in, I need to be on the mic. Let's say this came in over the wire in an XML or JSON payload, right? So the 2 is there. I'm parsing the 2, but it's converting it into green because that is what it is. And it supports hex and octal and decimal and all of that as well. The last thing here to show, oh, I'm over already? I missed all the other ones. I'm going to take 2 more minutes. You can't stop me. So here is my get symbols method. You say you want all the symbols for color, and it's going to walk through that list, and you see them all displayed at the bottom. All right, just one more thing I'm going to make a quick mention of before I leave the stage. I do have an example in here that shows an enum on top of a string instead of on top of an integer. And another thing that I have here is flags. So imagine that you have, let's say, an access, and it's a uint32, and you want to have like no access to something, or read access, or write access, or execute access, and you'll notice that all of these are bit flags, right? There's 0, there's 1, 2, 4, 8, 16, 32, and so on. And you can go and create values like this one, where access is write ORed with read access over here. And when you do the string equivalent of that, I have another helper method, and it will display read, comma, write. And if you have a string with read, comma, write, then it'll go and parse that and then convert all that back to the binary equivalent. So that's what my package does. Thank you very much for listening, and now I'll end.